So a tree changes radiant energy from the sun to chemical energy, and that chemical energy can then be eaten by animals and converted into whatever type of energy they need. For example, they can run and convert the chemical energy from the leaves into kinetic energy when they run. Hammering a nail changes mechanical energy, that kinetic energy of the hammer swinging down, into heat energy. God forbid, if you've ever touched a car crash or anything like that, you would notice that if something that had kinetic energy crashes and bends, then it would be hot. It would change kinetic energy into thermal energy, all right? Nuclear reactions will use that energy to change into heat, to heat homes. There's one in New York right over the border. An electric mixer changes electrical energy to mechanical, same way a fan might do that if you plug in a fan. And heat energy, it doesn't just get that energy from nowhere, that comes from a power plant, probably from chemical energy, natural gas, something like that, being burnt just like your car engine would burn gasoline. And in a lamp would change that power plant's energy into instead of motion energy, would change it into radiant energy, just like the sun was giving off. All right. So the big point, though, is that energy, when you get new energy, it doesn't just come from nowhere. It's just transferred from another source. So anytime something gains energy, no matter what form it is, it comes from something else that lost energy, and the total amount stays the same. All right. Okay, so I want to look at that idea when we analyze a pendulum. In September and October, we looked at pendulums, and we're going to bring that back around now. There are two types of energy we're going to be looking at with a pendulum, and it is GPE and KE. And before you draw this picture here, just let's go back real quick. So you copied down, what did we copy down so far? These two lines, right? And then you copied down some examples, 6 examples of transfer of energy. Now I want you to copy down the equation, all right? When we do math, we're going to be using this equation to represent conservation of energy, all right? So this equation is that ET, not phone home, more like energy total. And right there I have that total energy pointing at it right there, equals GPE plus KE. Okay, so as far as calculations go, if you add up the GPE, gravitational potential energy due to height, and kinetic energy due to speed or velocity, you add those up together, you get the total amount of energy in all of our problems. On a roller coaster, those will be the two types of energy. On a pendulum as well, those will be the two types of energy we look at. Okay, so copy that down, then we're going to apply it. I want you to take a second to pause the video and draw this picture of a pendulum. But before you pause it, actually,